Today, I'll cover the topics on electronegativity of the atom and also talk about polar versus nonpolar covalent bonds. So, what is electronegativity? Electronegativity is defined as the ability of an atom to attract electrons to itself. So let's look at the periodic table, and you can see that in the periodic table, the electronegativity increases as we move from left to the right. Fluorine is the most electronegative element, and carbon has an electronegativity of 2.5. This is the halogen family. So as we move from fluorine to iodine, the electronegativity decreases. So this is a table which has a list of all the common elements found in organic molecules and the electronegativity numbers associated with each atom. For example, hydrogen and phosphorus both have an electronegative number of 2.1. Fluorine is the most electronegative element with the electronegative number of 4.0. So electronegativity of an atom will determine the type of covalent bond between the two bonded atoms. So let's see what are the two types of covalent bonds. So the first one is called a nonpolar covalent bond. So in a nonpolar covalent bond, the two bonded atoms will share the electrons equally or near equally. The electronegativity difference between the two bonded atoms should be less than or equal to 0.4 for it to be considered a nonpolar covalent bond. This 0.4 number is an arbitrary number. So some textbooks may define a nonpolar covalent bond to have electronegativity difference of less than or equal to 0.3, but most identify 0.4 as the cutoff. Let's consider the carbon-carbon bond. In this case, the electronegativity difference between the two bonded atoms is 0. Let's look at another example, a carbon-hydrogen bond. Here, the electronegativity difference between the two bonded atoms is 0.4, and hence it's called a nonpolar covalent bond. Now let's move on to polar covalent bonds. In polar covalent bonds, the bonded atom will not share the electrons equally between themselves. The more electronegative atom will pull the shared electron pair towards itself, and hence the bond becomes polar. The electronegativity difference between the two bonded atoms has to be more than 0.4 for it to be considered a polar covalent bond. Let's look at some examples. Consider the carbon-nitrogen bond. The electronegativity of carbon is 2.5 electronegativity of nitrogen is 3.0. So the difference in electronegativity of the bonded atom is 0.5. And so it's considered to be a polar covalent bond. Polar covalent bond will create a dipole because there's a partial positive charge on carbon and a partial negative charge on nitrogen, and that creates the dipole. Dipole means two poles, and the symbol of dipole is right here. Let's look at another example. The carbon-fluorine bond. The electronegativity difference between the two bonded atoms is 1.5, and hence it's considered to be a polar covalent bond. And it also has a dipole. Carbon bears the partial positive charge and fluorine bears the partial negative charge. And so you have the symbol of dipole. The arrow starts from the least electronegative element and ends at the most electronegative element. So these are the important aspects of polar and nonpolar covalent bonds. The dipole may impart polarity to a molecule, and we'll talk about it in a separate video. So the most important thing to remember is the polarity of the covalent bond increases as the electronegativity difference between the bonded atom increases. Let's look at the amino acid cysteine, and let's try to identify whether each bond is polar or not. As you can see, there are several bonds in cysteine. There are NH bonds, CH bond, carbon-oxygen bond, oxygen-hydrogen bond, SH bond, and even carbon-carbon bond. So let's find out and classify each of these bonds as either polar covalent bond or non-polar covalent bond. So to help you with this, there's a table with the electronegativity of the atoms commonly observed in organic molecules. So you can see that hydrogen has electronegativity of 2.1, carbon and sulfur have electronegativity of 2.5, and you have oxygen electronegativity 3.5, and fluorine electronegativity is 4.0. Based on this table, let's create the list of all polar covalent bonds. So this is the list of the polar covalent bonds. So you have the OH bond, the oxygen-carbon bond, the nitrogen-carbon bond, and the nitrogen-hydrogen bond. All these bonds are polar. The reason they are polar is because the electronegativity difference between the bonded atom is more than 0.4. Also note that I have put the symbol of dipole. It starts from the least electronegative atom and ends at the most electronegative atom. In this case, hydrogen is least electronegative and oxygen is most electronegative. Same if you look at the NH bond right here. Hydrogen is least electronegative, nitrogen is most electronegative. Let's list all the nonpolar covalent bonds. So the nonpolar covalent bonds is the carbon-hydrogen bond. The electronegativity difference is 0.4. The carbon-sulfur bond and the carbon-carbon bond have electronegativity of 0.0. And then you have the SH bond. The electronegativity is 0.4. It's also considered as a nonpolar covalent bond. Let's try more examples. If you can try to rank the bonds based on polarity from least to most. So we have several bonds here. You have SH bond, carbon-carbon bond, OH bond, CF bond, even a boron-hydrogen bond right here. This is observed in borane. We have carbon-bromine bond observed in halides, phosphorus-hydrogen bonds observed in phosphine, NH bonds observed in amino acid or ammonia, and then you have HF, hydrofluoric acid. So to help you, I have this table with the electronegativity numbers of the atoms of interest. And I'll provide the answers right away, but you can take your time and rank those bonds and then check the answers. So these are the answers. So look at the pH and the carbon-carbon bond. The electronegativity difference of the pH and carbon-carbon bond is 0.04. So whenever there is a bond between two of the same atoms, it's a pure covalent bond, and the electronegativity difference is 0.0. In case of phosphorus and hydrogen pH bond, look at the electronegativity numbers here. Hydrogen and phosphorus both have electronegativity number of 2.1, and hence the difference in electronegativity between the two bonded atoms is 0.0 for the pH bond. Let's consider the BH bond. In this case, boron has an electronegativity number of 2.0. Hydrogen has an electronegativity number of 2.1. And so the difference is 0.1. Let's look at the carbon-bromine bond. Carbon has an electronegativity number of 2.5, and we have bromine right here. It has an electronegativity number of 2.8. So the difference between 2.8 and 2.5 is 0.3. And then let's move on to the next covalent bond, which is the SH bond. In this case, sulfur has an electronegativity number of 2.5, and hydrogen has an electronegativity number of 2.1, and so the difference is 0.4. So all these bonds which have electronegativity differences of 0.4 or less are non-polar covalent bonds. Let's look at NH bond. The electronegativity of nitrogen is 3.0 and of hydrogen is 2.1. So the difference is 0.9, which is more than 0.4. Recall that when the electronegativity difference is more than 0.4, it's considered to be a polar covalent bond. So NH bond is polar. So is the OH bond, which has an electronegativity difference of 1.4. If you look at the chart here, oxygen has electronegativity of 3.5 and hydrogen is 2.1, so that's how you get a difference of 1.4. For the carbon-fluorine bond, as seen in freons, you have an electronegativity difference of 1.5. And for a hydrogen-fluorine bond, the electronegativity difference is 1.9. It's very, very polar bond, because fluorine is the most electronegative element in the periodic table. Thank you for watching the video. Like and subscribe.